The world used to wait for discoveries, for products, for changes. Not anymore. Innovation has found a new speed. From years to months, to weeks, to a single day. Ideas no longer wait. Every breakthrough begins with data. We believe the next era takes shape when data becomes intelligence. OceanBase, the unified distributed database. Open source, multi-model, one engine for the most demanding workloads. Forged in one of the world's toughest digital ecosystems. Built for the speed of AI. AI never stands still. Models update. Workloads grow. Data continues to expand. From massive scale transactions to multi-model data. So the future of AI depends on one thing. How ready your data is to move, adapt, and evolve with AI. This is where Always Ready begins. Bring tomorrow closer. Create more resilient financial services. Power millions of payments in motion. Turn milliseconds into safer roads. Unify workloads without complexity. Scale business without limits. And keep critical systems always on. All at once. Always ready for mission-critical workloads. Always ready for data in motion. Always ready for what AI becomes. The next wave of data is already on its way. Will you be ready? OceanBase, always ready for the speed of innovation.
Hello everyone, welcome to OceanBase Hours. Now, let's welcome OceanBase CEO Evan Yang.
Hello everyone, I'm Evan Yang from OceanBase. It's great to connect with you here on OceanBase Hours. Next up, we will walk you through how OceanBase is doubling down on mission-critical financial workloads worldwide, while actively building out our AI database strategy, along with the key milestones we've achieved on our AI and globalization journey. All right, let's dive right in. Today, I want to talk about one simple idea that is always ready, from mission-critical modernization to AI innovations. Sounds like two different questions from two different eras, but what I want to say today is that they are really two stages of the same thing, and the word connect them is memory. Our story begins with this kind gentleman. His name is Henry Molaison. This photo was taken in the 60th birthday of him. Over his lifetime, Molaison has become the subject of hundreds of studies and over 2,000 papers in cognitive science and psychology. What made him special is not because he is a scholar, but because he was a patient, perhaps the most important patient in the brain research area. In 1953, when he was 27 years old, to treat his epilepsy, his parents agreed the doctor to remove part of the temporal lobes in both sides of his brain. Today, this decision seems almost unthinkable, but back then, it happened precisely because we know very less about the brain. So the risk arrived exactly as you would expect. Molaison said goodbye to the epilepsy, but in return, he got a big problem. That is, he cannot form new memory. He lived with this condition for the next 55 years. So let me start a question. What will happen when intelligence can still think, but can no longer remember? Today, we have a name for this condition. We call it anterograde amnesia. Molaison cannot forget his past. He's still sharp-minded and can hold a deep conversation. He's sincere and funny. But he always believed that He was 27 years old. He cannot remember his parent has already passed away. When he see his aged face in the mirror, he felt fear. But the fear only lasted a few seconds. Later on, series of paper about Malaysian scientists told us something important. Memory is not simply the same as cognition, as once people assumed. The two things are deeply connected, but play the different roles. But both are very essential to the intelligence. So cognition, like LLM, depends on making sense of what it is known. But the memory, built up over time, allows the intelligence to learn, to adapt, and reshape themselves. Computer science community accepted this concept very quickly, and then the roles became clear. Models handle the cognition, and the database built the memory. The building memory is, in a sense, the work of processing data, which exactly is the problem OceanBase, as a database company, has been working on for the past 16 years. Along the way, we have ran into two challenges. In 2010s, that is storing a massive amount of data, a problem of scalabilities. In 2020s, as Gen AI took off, it became the problem of managing multimodal data. So start with the first challenge. Just as a cognition, building memory is not easy. So from the small model to large language model, every step forward in the cognitive ability needs huge number of knowledges. In the same way, every step forward to the enterprise memory has been driven by the new demands, from storing massive amount of data to managing multimodal data. So just like OceanBase, if without the explosion of e-commerce, OceanBase, founded in 2010, could not be what it is like today. So by 2020s, OceanBase decided to go beyond China. The first stop is the Southeast Asia. Look behind. This is a dedicated moment. The Gartner Hyper Cycle shows that the technology of distributed database had to mature quickly from around that time. Southeast Asia sat right at the center of that wave. In those years, the new business models, the technologies they need got ready almost together. So the pace of change, unlike any time before, it was in that process we and our partner each remade ourselves. The first, habits changed first. In Malaysia, moving of people and spanning in Hari Raya is just like the Lunar New Year in the East or the Black Friday in the West. People love the ratio coming together, and they love the atmosphere spanning create. Anyone know Malaysia must know the due to Raya, the money handled in the green packets in the festival. Because all of them are small perch, especially because people prefer crisp notes in the packets. So Malaysia used to run short of cash every Hari Raya festival. So the Bank Negara used to issue over 750 million new banknotes to meet the festival demand. But 70% of them went directly back into the bank afterward. Mobile payment changed all of it, as online payment replaced the cash and the digital do-it Raya replaced the physical green packets. So the old problems simply went away. Touch and Go, the Malaysia's leading e-wallet company, is the biggest driver of this wave. And the database behind is OceanBase. So when the payment people, when the way people pay during the traditional festival changes, what does that mean to a database? It means 25 million verified users, 40,000 transactions per second at the peak and zero downtime. So a change in habits put extremely peaks right in front of the database. And second, the industry are being changed too. In recent years, the global value chain across the manufacturing and finance have undergone a profound transformation. In particular, the rise of licensed digital bank just streamline the transactions and address the gaps left by the traditional branch-based banks. So fundamentally change the structure, the cost structure of the financial markets and the supply chain. According to the kernel, once the operation stabilized, the licensed digital bank achieved an average cost-to-income ratio of 20% to 35%. That is at least 10 points lower than the traditional branch-based banks. And the product launch and the iterate cycle have been compressed from 6 to 18 months down to 2 to 6 weeks. And as manual intervention in critical approvals drastically reduced, and the operation cost naturally declined. Around the world, OceanBase are already powering digital banks, including Singapore's Enex banks. The third, services are changing as well. Let's turn to Indonesia, which may be has the most complexity delivery network in the world. Indonesia has over 70,000 islands, which 6,000 islands are inhabited. To cover such a scattered market, GoTo, the Indonesia's largest platform company, recruit over 3 million driver partners. That is more than twice of total headcount of every commercial courier company in the US. To run a network that complex, GoTo also add OceanBase to his toolkit. And today, the network has complete 200 million orders a month. And at peak, it generated 1 million real-time data points every minute. The platform company brought the third requirement. The transactional and analytical workload have to happen in the same place in real time, because dispatch decisions in GoTo or any other online business decisions like that cannot wait T+1. The third is the regulation environment is changing too. As the digital economy grows, the global regulation picture changed. Today, over 140 countries have digital laws in place. Southeast Asia especially has it. And the size of the economy, the shape of the industry changed so fast. So the older infrastructure under far more pressure to keep up. So taking bank as an example, beyond the compliance or security, banks need to look ahead to plan for the world they expected, rather instead of the world that they are seeing it now. So that infrastructure need to be very strong and very flexible at the same time. It means that need enough scalability for the extreme demand and enough room to work across the different environment if they operating across border. So this is also a very good opportunity for the open source distributed database. Today, more and more banks in Thailand, in Malaysia, and Indonesia are choosing OceanBase. So run region, but more regulatory regimes. Bank need infrastructure that adapt different deployment and data residency and compliance requirements. So infrastructure has to be multi-cloud, elastic, and able to scale out. This is not one bank's preference. It is a structural requirement of this market. So in just a few years from 2020 to now, Southeast Asia's economy has completely reshaped, deeper and faster than in many other periods. In that same process, OceanBase also reshaped. And things we always work towards, like the reliability, the scalability, the cost efficiency, and the seamless migration, earned real recognitions here. None of this was worked out in lab or proven again and again by Double 11, the largest online shopping festival in the world, and by product systems of hundreds of large financial institutions. As a key number behind reach a new level, our partners came to believe that this would be maybe the standard. Maybe this was the standard of the things that when you are modernizing your core systems of the future. So on the stressing of that, OceanBase has served over 4,000 customers, and we are becoming the first choice of global fintech industry, and also the key choice of the commercial banks who is modernizing their core systems, and also the new choice for many companies planning ahead. But what I talk about is not the number itself. The number really shows is that the architecture view we have been describing is no longer a proposal. It's already being adapted in a large scale and a real product environment. And the team had made a choice of facing the same situation, same challenge as you are. Before all challenges has even finished, a bigger wave arrived. That is AI. The first biggest challenge that the intelligence era is multimodality. In the past, this kind of data sat scattered across the object storage or the vector DB and become the dark data. Companies carry expensive storage costs, but find it very hard to get the value out of it. And over the past 2 years, in particular, because many people start to upload this kind of data straight to the large language model. So companies also started to feel security threatened. So why it matters? It is because the large language model, the multimodal data, has been a capital asset. That is what makes it the core of everything we can imagine. To interact with the real world, we need to understand multimodal. To make the agent performance better, we need to work with the multimodal. To advance the LLM technology itself, we should train on multimodal. We see in this way, this wave of AI attempt to build a certainty out of a high-dimensional uncertainty. But people naturally prefer certainty. And traditional database also built on certainty. They're built for the structured data and the relatively predictable workloads. But AI changed both of them. It exposed the limitation of architecture that never designed for the multimodal data and AI scale workload. So database have to modernize. And also adding the multimodal data keeps exploring those limitations on at least 3 levels. One is data cannot be managed in one place. Second, data get to move around far too often. The third is the model illumination cannot go away. So first, manage the data in one place. This is where the value multimodal data starts. We need to find a way to manage all of it property, like the data, the internet data and the text data, the LLM need, the image data, the sensor data that the smart vehicle need, the multimodal data and the video data that embodied AI needs. Our answer is OceanBase Lakebase, one data layer for every modality. We create something new. We call it multimodal table technology. By represent the multimodal in the unified table structure, we build a new kind of table. So it led us to manage the unstructured data in a structured way. Because for the historical reason, this is a way all the engineers knows and prefer. And it also can protect the company data through the strict permanent filtering. On top of that, since structured and unstructured data linked each other in the same table, so we can use SQL to do the hybrid retrieval with multi-way recall. It helps us to get a better research efficiency and precision. Once we have the multimodal data, soon we will meet the data gravity problems. That is the cost of the cost to moving data will claim much more faster when the volume reach to the petabyte scale. Beyond the serious latency problem and the high transfer cost, what matters most is the waste of people. Many data engineers spending half of the time pulling data out, transform it, clean it, and move it. In fact, over 60% of data engineers rank complexity of moving data across systems as their number one technical challenges. But these people are the people who should play a more important role in AI era, but they are wasting their time. So we're pushing so hard on in-database computing. Unless there's really no options, we want the algorithm work where the data sits, instead of moving the data over to sit next to the model. So taking sales voice recognition scenario as an example, instead of moving the sensitive voice data across the platform, computing can happen where the data already sits. So that will reduce the latency and the transfer cost, lower the data exposures, and make it easier to turn real signal into business actions. So whether something can be done or how efficient it can be done is not means it ends. It means we are entering the hardest part of the system because data silos still exist. So we need to build a bridge to connect them. And connecting them is not the end. We're aiming to rebuild a kind of certainty. So essentially identical raw data should resolve to a clear answer after abstraction with the metric and the logic. This is what semantic layer does. Let me give you an example. The same customer is an ID data in transaction systems, and the conversation data in service record systems, and the documentation in the contract systems. They exist in different formats. And guided by the business ontology, semantic layer unifying the three records at the same customer from business perspective. We believe the semantic layer is key to build high quality of context window, and therefore a key to holding back the hallucinations and improving the accuracy in complex enterprise analytics. That is the value we are really trying to create. Okay, this is all my sharing. Let me come back to the question I start with. What will happen when the intelligence can still think, but no longer remember? I believe everyone has gained some insights into that original questions. Regardless, I will also like to share my takeaways on it. This is a quote from the psychology pioneer William James. It is also the technical philosophy we believe. The art of remembering is the art of thinking. Thank you. Next, let me introduce our CTO Charlie Yang for his sharing.
Hello everyone, I'm Charlie from OceanBase. Now AGI is coming, and I think we need the next generation data infra to process more and more complex AI workload. Actually, database is the first generation data infra, and then OLTP database and OLAP database, they are separated, and then big data. Now, as for OceanBase, we think we should use Lakebase to combine both the advantage of database and a data lake to make AI processing much more real-time in a unified system. So today I want to share how OceanBase goes from distributed OLTP to AI Lakebase. OceanBase started in 2010. At first, it's a distributed OLTP database. It has lots of good features for OLTP processing. It can scale to more than 1,000 database servers, and we can add or delete OceanBase database nodes online without affecting the online business. It can achieve high availability, city-level disaster recovery. What I mean by high availability is that in case of any failure, OceanBase can recover in less than 8 seconds without any data lost. And OceanBase is cost-effective by using our online compression technology. We can reduce storage cost by 70% to 90%. And also, OceanBase is super fast. OceanBase broke the TPCC world record twice in 2020 and 2021. In 2021, we used 1,500 database servers to achieve 707 million TPMC in TPCC benchmark tests. It's not an easy job. As you know that we need to pass the TPCC ACID test. We need to achieve strong consistency in case of failure between different database nodes. We have had unified storage engine, unified transaction engine, unified SQL engine, unified multi-model, multi-cloud infrastructure, and then during these few years, we add more and more useful features for multiple workloads, including online analytics workload and also AI multimodal workload. We use one unified engine to process multiple workloads. The underlying architecture is our distributed storage engine. OceanBase can support both row store, column store, and row column mixed storage to achieve HTAP processing. OceanBase can be deployed in standalone mode and also in distributed mode. And on top of our distributed storage layer, OceanBase can support SQL processing, OLTP, OLAP, MySQL compatibility, Oracle compatibility, and so on. And also, OceanBase can handle NoSQL workload, including key value, JSON, semi-structured, search, vector, HBase compatibility, and so on. The benefit of unified architecture is that we can reuse the advantage of our distributed architecture, including scalability, resilience, low cost, and high performance. OceanBase also performs very good in OLAP processing. We also broke the TPCH world record in 2021, and we just compare the performance of OceanBase with ClickHouse using ClickBench. From this slide, you can see OceanBase is a little better compared with ClickHouse using 24 CPU cores and 500 GB memory virtual machine on the public cloud. Unified architecture is super good, but only database for AI workload is not enough. We need Lakebase. To process more and more complex AI workload, the data infra should not only process structured data, but also unstructured, or you can call it multimodal data. To process multimodal data, video, image, or like a document, we need separation of compute and storage architecture, which is built on top of object storage. And on the public cloud, it should be like AWS S3 or Alibaba Cloud OSS. To process the multimodal data, we need not only online query, but also batch processing. So we need open compute engine. And we should make sure that the next generation data infra should be designed not only for human being, but also for agent. It should be agent friendly. Number one, from relational table to multimodal table. You know that relational table is the underlying data structure for the OLTP database. It contains structured columns to process structured data, including integer, varchar, float, and so on. Structured data is not enough for AI processing. We need multimodal table to combine both the structured data and the unstructured data in one unified view. In the multimodal table, the unstructured data, which is LOB, should be treated as a first-class citizen. If the LOB is very small, it should be stored in row. If the LOB is very large, it should be stored out row automatically. And if the LOB is very large files, it can also be stored outside in external object storage systems and just keep the metadata in OceanBase. The benefit of multimodal table is to make sure that the AI processing of multimodal data is consistent. We can make sure that all multimodal data are processed using the same algorithm, using the same model, or using the same version of the model. All succeed or all fail, no partial success. Number two, from relational lookup to hybrid search. Now we have already had a multimodal table to form a unified view of multimodal data. Then we can build hybrid search features on top of a multimodal table. You know, vector database is very popular, and vector search is the most common search method to process AI-related scenario. But vector search is not the only way. Vector search is used to find similar data. Full text search is used to find exact match, and graph search is used to find relevant data. Relational filtering is used to narrow the scope. So we can combine all different search methods together into hybrid search to narrow the scope at first, and then to filter search to make sure that the result is more accurate, so as to reduce the token usage, to reduce the token cost of large language model. We also compare the performance of vector search of OceanBase with other popular vector databases such as Mirrorverse, pgvector, Elasticsearch. At the same recall rate, OceanBase leads in vector performance. We compare the performance of hybrid search between OceanBase and Elasticsearch with MS Micro dataset. You can see from this slide that OceanBase hybrid search is more than 30% faster than Elasticsearch. Number 3, from human-friendly to agent-friendly. I think with the evolving of AI, there should be more and more AI-friendly features added to the data infra, to the Lakebase. I just give you 2 examples here. One is database branching. You know, AI will always make a mistake, and we need human being to do the final confirmation. So we can do fork database, fork table at first, and then do the experimentation at the forked branch. If we succeed, just commit or just roll back if it fails. In the future, there should be hundreds of billions or even trillions of agents, and each agent will create their own table. So it will cause a problem called schema explosion. To reduce the number of schema, to reduce the number of tables, we need a feature called logical table to share the same physical table. We can also implement some useful features such as hot cold tiering. Typically, the data of the AI agent should be stored in the cold storage to lower the cost, right? When the agent becomes popular, we can move the data from the cold storage to the hot storage instantly on demand. Number 4, from SQL compute to open compute. You know, SQL is a very good language and I love it. And the SQL is used in online query, including OLTP, online OLAP, and also vector search, hybrid search. But besides online query, in the AI workload, we also need other tools such as Spark to do batch processing, to do ETL processing. We need DAF array to do AI processing. Online query, ETL, AI processing, they are built on the same multi-model table on the shared storage. So that is one copy of data, and we can eliminate the data transfer between different systems. Number 5, from schema to semantics. Every company, every enterprise, you have their own database or big data system, but we cannot do the AI directly on that database or on that big data system. Why? Because we don't have the semantic layer. AI doesn't know what does it mean. In OceanBase Lakebase, we have OceanBase OSI, which is built on top of Ant OSI. You know, OSI is an open standard, and Ant OSI is the Ant Group's implementation of OSI standard. It has been used and proven by lots of business in the Ant Group. We can use Ant OSI to define metric, to define compute logic, and to build context knowledge graph by automatic modeling, to do a lot of things automatically, sometimes with the help of our human being. And we can also add ontology layer to define business logic to form OceanBase OSI finally. This is the overview of our OceanBase AI Lakebase architecture. The bottom layer is our object storage, and then multi-model table built on top of our object storage to combine both the structured data and the unstructured data. And then we build open compute engine, OLTP, OLAP, search, and batch processing engine, ETL, AI processing on top of our multimodal data. The middle layer is our context layer. Context layer has two different components. One is data context, which is used by AI to know the private data of each enterprise. Other one is application context, which is used by AI to know the context of the application, let the AI to know the user. And the top layer is our application layer. We have already implemented two data agents. One is Data Studio, which is used by data engineers. Other one is Data Pilot, which is used by data analysts. I think our Data Pilot is also very competitive. The accuracy of our OceanBase Data Pilot is much better compared with our competitors because of we will build context layer automatically to make our data pilot more accurate. There are lots of benefits of our OceanBase Lakebase. Number one, our Lakebase can simplify the AI data stack. Traditionally, we will use lots of open source tech stack, such as Lakehouse, right? I talked with lots of CTOs, CIOs, and each enterprise will have for about 5 to 10 different components, including Lakehouse, Redis, HBase, MPPDB, Elasticsearch, Flink, and so on. So they need a lot of people to do maintenance. And the TCO, the real TCO is really high. In OceanBase, if you migrate your tech stack to OceanBase Lakebase, all you need is one unified engine. All you need is one unified system to do online and offline processing. So the tech stack should be much simpler compared with before. Number two, Lakebase closes the online-offline data loop. I think real time should be much more important compared with before because it's designed for agent. And AI agent will never sleep. And AI agent will just make a decision at the moment when they see the data. OceanBase Lakebase is built on top of our multi-model table and then stored in shared storage. We can do the online processing and offline processing with one copy of data. By using this kind of architecture, we can eliminate the data transfer between different systems. So the data, multimodal data can be processed much more real time compared with before, compared with other systems. By now, OceanBase has two different product families. One is our traditional database, distributed database to handle HTAP workload. Our distributed database has a lot of advantage, including scalability, availability, low cost, high performance, and so on. The other one we introduced today is OceanBase Lakebase. OceanBase Lakebase engine plus OceanBase Data Studio plus OceanBase Data Pilot is our solution for every enterprise to go to use AI effectively. I think the Lakebase to combine structured and unstructured data into one unified system to make AI processing, to make unstructured data processed in real time will fulfill the requirement of AI, and it should be the next generation data infra for AI. That's all. Thank you. And next, I want to bring in an old friend of mine, engineer. He is a principal analyst from Forrester to talk with me online about the Data Plus AI platform. Hello, engineer.
The topic of today's chat is
the future of production AI data platform, which I think resonates with many of you because nowadays every organization is seeking to utilize AI in production to boost value. Today, I'm very honored to have a guest and friend with me, principal analyst, engineer from Forrester. Engineer, thank you so much for being here today. Could you please give a brief introduction to yourself?
Certainly, Charlie. It's a pleasure and an honor to join you in today's conversation. My name is Indranil. Like you said, I'm a principal analyst at Forrester. I cover data and AI at a broad level with specifics in data management. And before that, I'd been in many technical roles, including 14 years of being CIO before I joined Forrester. It's a great pleasure once again, Charlie, to meet you and have a chat with you.
Very impressive. I think it's going to be a very insightful talk today. Let's get started with a general question, engineer. What are the market trends?
That's a great question and sometimes very difficult to answer, but I'll try and keep it to a few broad market trends. The first one I'm going to talk about is around how intelligence is moving to data, and that is reversing a decade of data gravity flows. So what I mean by that for years, if not decades, we ran on one assumption that moving data to where compute lives. But what has changed is the consumer. Now it's not anymore human consumer, but we have AI systems and especially agents which are acting in the moment on the live data. So a copy that is 3 seconds old, for example, is a copy, which can be wrong, and an agent acting on a wrong copy may end up being a liability and not a productivity gain. So the flow is reversing. Retrieval, inference, and even governance are moving down to the data layer itself, because that is the only place where freshness, consistency, and authorization all hold at once. The second trend I want to talk about is that, which I sort of alluded, that machines are replacing humans as the primary consumers of data platforms. What I mean by that is that data platforms that we run today, quite a number of them were designed for a human to be on the other end. Humans, along with programmatic systems, they queried databases. They had some tolerance in terms of latency and working business hours so far human beings are concerned. But agents have none of that. They query continuously at machine speed around the clock, and they need structured facts, unstructured context, and even relationships in a single authorized step. And that changed what data platform used to be. So concurrency in profile changes, access control changes, and performance expectations are all changing because an agent's context is finite, and every system it must touch has a real cost. So these things need to run at the consumption time so far as agents are concerned. The third element is around database and AI platform capabilities which are converging. What I mean by that is that if you think about even enterprise stack a few years back, Charlie, you will see a clean line. Databases below and AI platforms above, with embedding services or retrieval layers and orchestration in between. That line is dissolving from both directions. Databases are absorbing what used to sit above them, for example, native vector retrieval or embedding integrations and agent context assembly. And AI platforms are reaching down to own operational data. So both camps are converging on the same product surface because both learn the same lesson that AI is only as good as its access to live, governed, trustworthy data. So for buyers, this means that the database decision and AI platform decisions are becoming one decision as we are moving in this market.
I think you give us a very complete picture, engineer, and I totally agree with all of it. I think the next generation data infra should be designed for AI agent, not just for human beings. And I want to emphasize that real time is much more important in the AI era. for the last 20 to 30 years, analytics was a batch business. T plus 1, T plus H, mininet. Data was processed in scheduled time. It works because a human was reading the report regularly. But an agent doesn't. An agent asks its question just at the moment the business event happens and it acts on the answer immediately. It changes how I rank the benefits of convergence. Most people put cost first. One platform, less data movement, less integration. That's true. But I'd like to put real time at least equal to cost and maybe ahead of it, because when transactional data and analytical data live in the same system, the agent is reading data less alive, not a copy from last night, which is really why I think this conversation matters. I spend a lot of my time with CIOs and CTOs. They are rebuilding that data platform right now, not because AI is fashionable, but because their analytical stack was designed for a new customer called AI agent. This job isn't to make the old platform faster. I think it's also to rethink what an AI data platform should be. And that's my next question for you, engineer. What does convergence look like in a modern data platform?
Thank you, Charlie. I think you sort of alluded towards that as you were speaking, and I sort of also mentioned that one of the themes that there is definitely, when I talked about the data and AI is converging, but there are some of other elements which are converging. If you think about the 5 forces or management or sort of the industry trends I just talked about, if you look into them, they collectively look towards one word, which is around convergence. And let me explain what I mean. I already talked about how data and AI platforms are converging, but some of the additional convergence elements are the following. The first one is around multi-model. Separate engines per data model existed, separate systems per workload existed, separate layers and for intelligence, existed for long. And we accepted that. Like you said, copies of data used to happen for analytic loads or for transactional loads. Those things worked well. But the modern approach, especially with AI and agentic AI, is changing. The data models are actually converging into one engine so that relational facts, documents, relationships, and even embeddings live under a shared transaction. That is actually the multi-model core. And the intelligence converges into one platform during retrieval and operations, because more and more agentic AI needs different types or different models or different types of modality of data. And when those things are needed at a single transaction, that needs to converge in a way. So that's the first convergence around model convergence. The second one, which you also sort of touched upon, is around what we call at Forrester translytical. I said earlier that intelligence is moving to the data. And here is the architectural consequence of that. Every copy of data carries an age, and every pipeline hop adds to it. For a human being reading a dashboard, a few seconds or even few hours of staleness is invisible. But for an agent acting autonomously, this staleness is an error. So an agent approving a transaction, an account balance, for an example, 2 seconds ago, is going to give a wrong decision or friction if that doesn't get translated into that analytical world where analytics will run on them. And that means more and more transaction and analytics are converging into a translytical world, as we called in Forrester. The third convergence, which is a very important one, is, I believe at least, is governance. Think about how we govern today. A person authenticates, a permission model checks them, an audit log records them, and that works because in the main humans acts occasionally and predictably. But agents act continuously, concurrently, and sometimes in a way that nobody has scripted. And that means the governance layer cannot be bolted on above the data anymore, or even in the middleware or in an external control plane. And that becomes a bottleneck or sometimes a challenge for today's agents to work in a governed sort of situation. The answer to that is that there's a convergence and enforcement at the point of action so far as governance is concerned. For example, the agent's identity is declared purpose and the enterprise's policy evaluated in the engine at the point where a data is being retrieved or updated by the agents. It cannot stay separately. It has to converge in the data platform. So that's the third point. The fourth point is even the query surface is converging. So what do I mean by that? That a developer or every additional engine is some sort of friction and attacks. Another driver, another query language, another connection to secure, or some of the mental model to hold. So think about what it means for agents, which works 24/7, and it even doesn't have a particular way of looking at things which probably a developer would have. And that means that the agent should have even much more ease in terms of how it queries the different systems. So for that reason, the convergence of even the query is happening. That means that an agent should be able to converge with a converged query surface, which multi-model and translytical systems do give, that there is a single query surface like SQL, which can even combine with JSON or time series or geospatial or even vectors, and that can give those response back. And the agents don't necessarily need to know that when to use what type of query language. So those are the top four sort of convergence, apart from the one I just talked about in my earlier answer to your question. What are you seeing from your side, Charlie?
Engineer, I totally agree with all 4 points you just mentioned, and I love the word convergence. And I also would like to add the same convergence is happening on the vendor side. Everyone is working towards the same place, just from different starting point. Some started from the lake and are now adding database capability, just like Databricks. Databricks is doing exactly that this year. As for OceanBase, we started from the database and we had added the lake. Different roles, same destination. At the OceanBase, we call our approach Lakebase. Lakebase is our engine. It converges the database and the lake into one unified system. So structured and unstructured data are processed in the same place in real time or in batch. We released our newest Lakebase engine on June 29th this year. On top of our Lakebase, we built a semantic context layer because a modern data platform is no longer only for human beings, it's also for agents. That layer has two products. Data Studio is for the data engineer, is where governance happens and where context gets built. The unified catalog is part of it. Data Pilot is for data analysts. It carries the business ontology and it translates natural language to queries against your data through that ontology. So Lakebase plus Data Studio plus Data Pilot, that's our AI data platform. And if I had to name what's distinctive about coming at this from the database side, convergence for us is mainly about putting data in one place to cut costs. It's about the freshest data living in the same system where the agent asks the question. We think real time may be more important. That part is very hard to add afterwards. So engineer, let's go to our last question. How do you think buyers can actually approach this?
Thank you, Charlie, for that question. I will use my, practical side of my brain to respond to this. And some of the answers, could be very contrarian in nature, especially the first one I'm going to talk about. The most of this talk, we talked about this agentic thesis, which is real. AI and agents are very important. But at the same time, our research, and I'm sure you will also agree along with your the audience today, that the relative lack of ROI of AI is also real. So what I would like your audience today and the potential buyers to start thinking about slightly differently. And what I mean by that is that choose your data platforms to your current load. Make that as your first, point of choice. Definitely, you need to start thinking about AI and agentic AI and all those good things. So you need to keep them in mind. But if you are going to go into your CFO and going to say that I'm going to buy a data platform just for AI or agentic AI, given this challenge of the market we face, that where relative ROI is much lesser in number, then you may get a pushback. So when you are modernizing and choosing a data platform, first make sure that it works for your current workload, and then you future proof it for your agentic AI workload. So it's not or, but it's an and. So that's what I just want to make sure that that potential buyers keep in mind.
So I want to build on your point because I think it's the most important thing said in the whole conversation. Don't justify the platform on AI alone, justify it on a problem you already have, and then make sure the platform is ready for AI. Let me add three things on how to actually start. Number one, I think we should find the timing and find the pain point. A data platform project is very expensive, and most of the cost is migration. So the value has to be a business value, not just a technical value. If you can't, then the business owner who's waiting for the result is a long project, no matter how good the architecture is. Number two, choose the right first project. Two kinds of work works well. One is a new AI native application. There's nothing to migrate, so you move very fast. The other is an existing analytical workload you want to turn into natural language, agent-driven analytics. What always never works is let's migrate the whole legacy system first and then do AI. Number three, and this is the one I'd really suggest, start with your high value data, not with all of your data. Let me give you a real number engineer. At Alipay, we moved less than 5% of the data onto our new AI platform, and that 5% serves more than 90% of the hot queries. The other 95% is code data and is state where it was is in the legacy system. The legacy system isn't unified and it was never designed for AI, but it doesn't matter. That's completely fine. Nobody had to wait for it. So small scope, real pain point, high value data first, then scale. And the first project has to succeed because if the first one produce no business result, nobody is going to fund the second one. So I think time is nearly up, and engineer, we will end the conversation. Engineer, could you please close in one line?
That's a difficult ask, Charlie. You now put me on the spot to summarize for the last 20-25 minutes what we've been talking about. But I will give it a try. I would say that because we started talking about convergence, I'll start with that, saying that converge where the seams cost you and specialize where scale demands it. And then I'd like to add to say that whichever platform you choose, make sure that the data platform assists with current workloads, current challenges, and future-proof your data estate for agentic AI workloads as well. Thank you, Charlie.
Yes, it's not an easy job. And I will also close in one line for my point. I think enterprise needs a new AI data platform is designed for AI, a converged Lakebase, and step-by-step migration should be a very good strategy. So, engineer, thank you. This was very useful, and I think our audience got a much clear map of where this market is going. To everyone watching, thank you for your time. If you are rethinking your data platform for the AI era, we'd love to continue this conversation. Engineer, thank you again, and bye-bye.
All right. Thank you, Charlie.
Let's go to our next fire chat session. So I would like to introduce our three speakers. Three speakers are already here. So Sean, he's very famous. He's the co-founder and CTO of Ninja One. And Banu, he's our general manager of OceanBase India. And Suraj, he's the architect, solution architect of OceanBase. Let's welcome.
Thank you, Charlie. And let's get started for this next 30 minutes of industry insights. First, of course, would like to introduce once again Sean. Thank you for being here. He being the co-founder and CTO of Ninja Van, I think he has been driving logistics business, one of the largest logistic business in Asia, with complete perfection. So thanks for being here. And thank you, Suresh, for joining us. Suresh being our solution architect, he's always in the center of all the discussions, right? So thanks, Suresh. So I think I just wanted to first start with a question, right? If there is a question you would ask to anyone 10 years ago, naming them one mission critical system, a typical answer in those days was a core banking solution. But I think things have changed a lot since then. Mission critical is not just banking, but it's any industry which is serving their customers directly. And since I manage business for India and neighboring markets, there is one trend which is very, very common. If it is a payment company and it goes down, they don't just have annoying customers, but they lose revenue, and they may be featured on the front page of some big news media. If it is a logistic business and they are unable to track parcels in real time, right, there is always leads to delays. If there are digital services who do not have consistent data, then you lose customer trust, right? And this could just happen because of just one bad transaction. So effectively, all these industries right now are demanding the same thing which banks used to demand, which is their systems should be highly available today. They should be able to scale, especially during festive periods, or they should be consistent at all times, or they should be resilient regardless of the entire data center going down. They should still be continuing to serve their customers, and more importantly, the cost, right? The cost should not continue to explode while they are innovating, right? So I think this is all what we're going to unpack in today's session. And with that, I will probably get into my first section. So the first section, which I'm going to talk about, is what modernization looks like in practice. So I have some list of questions in my cards. So I'm going to ask both of you one at a time. So I will do an opening question to you, Sean. From where you sit, what actually goes wrong when a system cannot scale or cannot change fast enough? And what does that failure look like on ground?
Right. So obviously, our business is really seasonal. Peak periods for us, like 10, 11, 12, Tet, Lebaran, you name it. People find reasons to make sales, right? And I think in the e-commerce industry, when these kind of peaks come, we're looking at 10, 20x traffic. So in most applications, I think the hardest part to scale would be the stateful side of things. The stateless application layer, you can just deploy as many instances as you want, right? And if you don't have a scalable transactional data architecture, and in our old days, we really faced this, right? Unexpected volumes, so many API requests, TPM to the database goes up, slow queries adds to it as well. And you just start to see scans are not going through, right? I want to figure out where this parcel should be routed to. Can't figure out. Drivers, they log into the app to see where their next destination is. Maybe they can't, right? Can't do the jobs. Writing data into the database as well, or the proof of deliveries, right? That all gets delayed. And for us as a business, interestingly, the kind of SLAs that are being put on us are not just did you deliver the parcel, within 1 day or 2 days, right? We're even rated on once a event happens, like a scan comes in the warehouse or a parcel gets handed off to a customer, how long does it take before we send this notification to our customers, right? So there's even an SLA on notification time. And all this goes down to the ground when your database can't handle the load, right? Interestingly, when we were designing for such a failure, we started doing a lot of caching on the driver app, right? You store all the data offline just to cater to instances where the database couldn't handle the load. And when drivers were trying to push their proof of deliveries, if the DB was down, obviously it's not going to accept the request, right? And once the database started to recover, there was broadcast storms because so many driver apps were having so much queued up messages, right? And it's almost like a denial of service on your own internal systems, right? So it's a very huge problem if your database cannot handle this kind of load. I think there's another one. This is not so much on outages, but scalability. Also, you have to take into account how do you continuously improve your product. And this failure is kind of silent because when you don't have a database infrastructure that allows you to make changes easily, right? Let's say a table migration, altering a table, adding a column or something like that, right? Especially for large table, takes a very long time, right? Engineers would tend to not want to take on this task because the risk is enormous as well. And these kind of failures are silent because you would see that the business wants some features, but because the task to do it and migrate it on a database is so difficult, it gets pushed back, right? And how you see that failure is your business users, they start to try to do all these processes offline, maybe in Excel or Sheets or something like that, just because engineering team couldn't build that feature. Yeah, so I'll say a very strong database, infrastructure is really critical to both scale and extensibility of your product. Yeah.
Thanks, Sean. So yeah, I think traditional systems probably will push back a lot of initiatives is one takeaway I can take from that. Suresh, I'll come to you. And I think can't be better than starting by talking about who uses OceanBase today and talking about real stories. So I wanted to talk about two. Touch and Go, which is probably the largest app in Malaysia. And we have GoTo Digital, right, which is almost across different industries, ranging from taxi to food delivery to e-commerce. They're almost everywhere. So the question to you is, before OceanBase, how were their traditional systems breaking up? And how did OceanBase help them solve the problems differently?
Thanks, Banu, for the question. I'm really honored to be part of this Fireside chat and to share the stage with Sean. And I can actually relate to the problems that you just described. But then let's talk about some of the real world use cases where OceanBase has really performed. So one is Touch and Go. Touch and Go is a well-known brand in Malaysia. It started off as a toll payment system, but then eventually diversified into digital payments and payments services. So one of the challenges that Touch and Go was facing was sudden spike in traffic, similar to what Sean just described in Double 11 events, shopping. So during these events, it becomes really difficult to scale seamlessly and to absorb that traffic. And that's one place where OceanBase played a big part. OceanBase being a native distributed database, it allows seamless scalability. You can just add nodes and the data rebalancing happens automatically, right? The other challenge that they wanted to tackle was from a regulatory compliance perspective. They wanted to explore multi-model and multi-cloud and multi-region resiliency. And that is something where OceanBase also played a part. Right now, some of their use cases are actually running on multi-cloud and multi-region deployments. Now coming to GoToFinancial. GoToFinancial had challenges related to data pipelines, complex data pipelines. It not only made the architecture very complex, but also it added to the cost. Now in OceanBase, we call it as EdgeTab, which is hybrid transactional analytical processing, which allows you to run transactional workload as well as analytical workload on the same database. That makes your architecture much more simpler. And with compression, which is one of the unique features of OceanBase, and multi-tenancy, they could actually save up to 50 to 60% of the cost. So these were some of the real-world problems that OceanBase actually has resolved.
Thanks, Suresh. Okay, so moving on to the next section. This is dedicated to you, Sean. This is the CTO perspective on always-on operations, right? And I think you of course have been running NinjaVan for almost a decade now, and you've seen the growth, right, in Asia, and you've managed systems which are always on. So my first question to you is that in logistics specifically, what makes a system mission critical, and what breaks in real world when the data is wrong or the system is down?
Okay. So in logistics, I think for us, we are mainly tracking a parcel, right? And to us, actually, a parcel is not just a row in in a database. Actually, it's a chain of custody, right? And interestingly, if I'm not mistaken, OceanBase was created for financial, right? And because for logistics, this whole chain of custody, you want to know who is accountable at what point of time, right? Where the parcel is. It's actually closer to a bank ledger than a lot of people realize, right? So what could go wrong? I can think of two things. One is availability, right? When the system is down, like I was talking about, you can't get the job done, right? And for us, logistics is 24/7 operation, and if the trucks gotta leave the sort center at 2 a.m., right? The truck's not going to wait for the database to be up, right? And if you can't figure out what to put on the truck, the delays, they're cascading, because tomorrow you have to deal with all the mistakes that is going to happen, right? And all these mistakes cost money as well. The second one I would say is along the lines of consistency, right? Especially when you have distributed systems, right? You don't want to get into a situation where you don't know who is correct, right? And for us, so many different use cases. For instance, cash on delivery. Every time a driver picks up, delivers a parcel, collects the cash, right? That record gets written into the database. And when he comes back to the sort center, he needs to hand over that cash that he has collected, right? And if we don't have that value correct, right, how are we going to know how much cash there is in the bag? That's operational. If we don't know that, game over for us, right? Yeah. So I think these are the two things. Yeah.
Okay. Quite interesting insights about how logistic business really works. The next question I wanted to ask you was more on innovation. So does your data foundation help you move quickly on new initiatives, or does that hold you back from releasing new features in time? And because end of the day, there is a tech behind it. There's apps, and then there's this database layer which is empowering you.
Yeah. So I think the biggest fear is schema changes, new features. Like yeah, whenever we have to deal with tables which are so large, we almost hardly see features being built around that, right? The next one I think would be, yeah, I mean, even if you have to do that, how difficult is it then to run the migration? I remember the old days when we were on MySQL and we were using like the Percona tool set. We had to use, what was it? Some Percona migration, but then we shifted to the GitHub Ghost, right, which is the GitHub Online Schema Change tool. Just to make sure that, you know, when we were migrating it, we also had to deal with the amount of pressure going into the database so that we do not affect too much on the, you know, the load on the production transactional systems. Yeah. So, yeah, I really think that from my experience, it's always the database, right, which creates a lot of challenge and a lot of friction when it comes to innovating. Yeah.
Sure. Thank you, Sean. That was really, really helpful and insightful. I wanted to move to talking about the common data architectures. And I wanted to come back to you, Suresh, on this. So OceanBase is a unified solution, right? Which means it can host transactions, it can host analytics, multi-model, AI, all into one, right? So if we start from transactions, how does OceanBase deliver scale, availability, consistency, which all we have been talking about till now, but making sure that the sharding logic is not pushed down to the application?
Yeah, that's a great question, Banu. In order to understand sharding, I think we need to understand how the database has evolved over the years. In the last 5 decades, initially, there was relational database, mostly single node architectures, which was back then for those workloads, it was enough. You could handle relatively large databases on single node and you could actually achieve a good performance. But with the internet boom and with e-commerce and digital native industries coming in, the challenge has been to how do we handle large data? And that's where sharding comes in, right? So initially, the sharding logic was mostly handled by applications, which was application heavy. Eventually, it was replaced with middlewares, which was having the knowledge of where the shards exist, and they used to do much of the heavy lifting. But then the architecture becomes much more complex. You cannot guarantee consistency. That's when the native distributed architecture of OceanBase came in, way back in 2010. So with the native distributed architecture, it becomes much easier for you to scale. But then what OceanBase made sure is that with the distributed transaction being introduced, we don't lose out the single node performance as well. So there was a lot of innovation that went into. In fact, to relate back to Sean's point, wherein making schema changes of large tables, which I have also gone through personally in my career, now in OceanBase, most of these operations are online, which makes it much easier. It kind of reduces a lot of workload on the DBA side and the data architects. So this is something that innovation has OceanBase has done and helped customers achieve.
And also a quick note from you on, so we've talked about transactions, right? When I go and talk to some of the business owners outside, when I tell them that OceanBase can also do analytics, they say how, right? Because that's the most common answer which I'll probably get. So can I talk about how OceanBase does real-time analytics without a separate analytics stacks, but everything into one?
Yeah, this was also one of the things that OceanBase identified as one of the gaps that the industry had, because there was no way to simplify the architecture. Traditionally, the way it is done is you have a separate operational data store, you have a complex data pipeline, and you have a dedicated data warehouse where you do the analytics. The problem with that is not only complex data pipeline, it's very difficult to maintain it. Also, it introduces latency, T+1, T+2, sometimes hours. So which means that you cannot access real-time data. So for use cases like AML, fraud detection, where instant information is required to make decisions, you cannot do that. And that can be done in OceanBase using HTAP feature, which is hybrid transactional analytical processing. And this is done through a custom format, storage format that we use, which is called PAX format. So that's something that is useful not only for these kinds of use cases, but also for agentic AI use cases as well.
Okay. And a quick one from you, Sean, like we are talking about real-time analytics. How much does that matter for logistics?
It matters a lot. So in the early days, what we did was because we wanted to give our users access to dynamic queries, right? Because when users say I want A, I want a dashboard B, right? Engineering teams would have to build something very specific. So we turned it into a self-service platform using open source tools like Redash, Metabase, but they were reading off a transactional database, right? Not analytical database. And we built that by putting on basically a slave architecture, right? But it gets very, very complicated when you have multiple database servers, multiple schemas, and you're trying to consolidate that into a slave, because you need to be able to join the data as well.
Yeah.
Right? So we built that, and it was very, very difficult to scale because you also start having a lot of the noisy neighbor issues where, okay, it works, right? But when you have one guy who has no idea how to write a performant query, or it might not be because he doesn't know how to write a good query, it could be the index is just not there in the table, right? And then you start having your other customers complaining because someone messed it up for them. Yeah. So I think having a architecture that allows you to have, like, both that basically the HTAP thing, right? Your relational database and your column stores. That simplifies a lot of things, and even more so if you have features that allow you to control the utilization, the IOPS or the compute on each so-called tenant, right? That also helps solve the problem. So we did move this architecture of like the MySQL slaves to a HTAP solution, and that made our lives tremendously easier. Yeah.
Thanks, Sean. Thanks for sharing that. And now I'll move to my last section, which is how do you modernize your core to AI on live data? So coming back to you, Sean, my question to you is, does AI need unified data to work well? And in this era, do you think the adoption of unification, unifying the data, would continue to increase?
Most definitely. I mean, in logistics, I think we're very much multimodal in terms of the kind of data we're storing, right? We're storing proof of deliveries, images, text records, geographical records, right? Whatever you can think of. With AI, I think it's increasingly important that your data infrastructure is simplified. I mean, in those days we had, like, for each use case, text search, right? We have Elasticsearch, we have vectors, we have another vector. So you have so much technology in that stack, right? And for AI, I think the most important thing in AI is that AI needs context windows and not context switches, right? Because if you have data split across different systems, when a human looks at it, a human might be able to tell you, okay, something is wrong, something is not agreeing, right? But you always notice that AI is very affirmative in nature, so things might go wrong. But bringing it back to the point is AI works very well when you give it the full context in the simplest way as possible. Yes, You could still do that with disparate systems. You can build an orchestration layer on top. But why do that, right? If you can keep it simple, it's always the best strategy.
Yes, indeed, and I completely agree with those remarks. And I think in continuation to that, Suresh, I wanted to come to you. Like Sean just mentioned, different multi-model formats, right? You have it's not just tables. We're talking about files. We're talking about images. We're talking about text, documents, a lot more. So in that regards, can you talk about OceanBase Lakebase? And how does it unify structured, semi-structured, unstructured data into one solution?
Definitely. I totally agree with whatever point Sean made, right, in terms of context. Now, context is needed by AI, but context rarely lives in one single database table, right? So, for example, if I take a transaction, the transaction could be linked to a contract. It could be linked to an email. It could be linked to a vector embedding that belongs to the customer. So when you look at everything as a whole, there is context, right? And the idea behind Lakebase is similar. So what it is trying to do is the principles, database principles that OceanBase is already good at, like transaction analytical and real-time access, it is bringing that to a next level where it can actually store structured, semi-structured, and unstructured data. So what it basically means is that OceanBase does a multi-model table abstraction that allows you to store relational, JSON, geospatial, text, video, images, all this data in one data platform, right? So with this, what it does is it actually makes online serving and offline processing of data with a single copy of database, and which is closer to the application and the agents so that they can make faster decisions. So with this multimodality, what happens is in OceanBase, you can also do hybrid searches, right? And the next trending concept, which is LTAP, is what we are trying to introduce as well, which is lake-based transaction analytical processing with that. So in simple terms, Lakebase is a database that can understand transactional as well as analytical queries as well. But also it can actually understand broader context that AI requires while retaining the reliability, consistency, and governance that enterprise expect from databases.
Okay. Yep. It is definitely, again, it all comes down to unification. And I think with we are almost about off time, so I'll just squeeze in one last question to you, Suresh. We also know about Data Pilot as a tool for OceanBase, and I think it's trending in news. It holds #1 spot in DAppStep, global leaderboard. Can you quickly talk about Data Pilot? And is it true that the business users can analyze their live data by just asking in plain language?
Indeed. So Data Pilot, recently it has been getting a lot of traction. So Data Pilot is basically agentic AI-based real-time analytics solution using natural language to SQL, right? So what it means is you can actually give the access to Data Pilot to your schema, and it is able to build ontology on top of it and a semantic layer and build context on it. And it also allows the user to give their own context to it so that it understands the business, but it also does it automatically. So with this, what it means is this powerful feature can allow a CEO to get the reports that he wants immediately. He doesn't have to go to the engineering team and tell, I need this dashboard, I need this reporting, can you please develop for me? He can do it on his desk just by asking in natural language the question that he wants to know and take decisions immediately.
All right, thank you, Suresh. So I think that brings us to the end of the session. So once again, I would like to first thank Sean for all your insights which you've shared with us. The real grounded facts which you've shared, which are definitely insightful for everyone who's listening to us. And thank you, Suresh, for talking about how unification is moving towards where it should be. So I think before we end, I just wanted to conclude by saying that if there is one getaway from this session, would be this, that no matter what industry we talk about, right, whether it is mostly digital, of course, but could be logistic, could be SaaS businesses, could be digital services, the business model looks different. But when we talk about challenges, more or less, it comes down to the same thing, right? It's either someone is struggling to scale, someone needs availability, someone needs consistency, someone needs to cut down cost, someone needs to have a platform where they do not want to refactor or re-engineer every 2 years. And I think that is where OceanBase is built to solve these fundamental problems of growth. But more importantly, I think the re-engineering which I talked about, I think this is one cost which nobody sees it coming, but it kind of consumes a lot from the businesses. And more importantly, going in future when we are now in the AI era, it gives you a strong data foundation, right? So that you can just plug and play your AI scenarios in future. So thank you once again, and thank you all for listening in, who is tuned in. With that, we'll close out today's session, and thanks all once again.
Thank you for watching the OceanBase Hours live event. We look forward to seeing you again next time.